All right, in this next lesson, we're going to talk a little bit about solving for a missing piece. So if we are using area formulas, we can actually work our way backwards if given the area and some other information and figure out one of the missing pieces of the shape that we're working with. So in the first one, it says a parallelogram has a height of 10 units. If the area of the parallelogram is 120 square units, what's the length of the base? So the first thing to do is, because we're talking a parallelogram, on our formula sheet, our formula is area equals base times height. So the pieces that we know the height is equal to 10, and we also know that the area is equal to 120. So what we do is we plug in and we're solving, we're looking for the missing base then. So area equals base times height, so we're going to have 120 equals the base times 10. So to get the base by itself, we have to divide by 10 on both sides. And we're going to learn that the base is going to be 12. We have to give it the correct units though. So we're just talking units, it looks like. So base is actually just a length, it's a linear length, so it's just going to be 12 units. Remember, area is the only thing that gets units squared. In the next one, the area of a triangle-shaped monument is 20,130 square feet. So it did tell us it's a triangle shaped. So our area is 1/2 times base times height. We already know that the area is 20,130 square feet, and we know that the base is 22 feet. So it wants to know how tall is it. We're looking for the height. So area, which is 20,130, equals 1/2 times the base, which is 22, times 8, which would be the height. In this one, this is kind of like when we were solving the simple interest problems. We actually need to multiply those two. So half of 22 is 11h equals 20,130. And if we do 20,130 and we divide by 11, we get 1,830 is the base then. So this is talking about feet. The base is just going to get the label of feet then. Last one up here at the top, the area of a circular sandbox is 200.96 square feet. So area is pi r squared. We know the area is 200.96, and it wants to know what's the radius of the circle and then what's the diameter. So in our formula, we're going to have 200.96 equals, I'm going to go ahead and plug in 3.14 for pi times r squared. So to get r squared by itself, we have to divide by 3.14. So I'm going to get r squared equals 64. And r squared is the radius squared. So whatever number the radius is, we take the square root, so we get that 8 is the radius. We're talking about feet squared for the area, so this would just be feet. So we can say the radius is 8 feet, and we can say the diameter then would be 16 feet because that would be doubled. Next one is a multi-step problem. So it says the perimeter of a rectangular garden is 36 yards. One side has a length of 12 yards. Find the area of the garden. So we're given the perimeter, we're given one side. We have to figure out what the other side actually is. So if you remember, the formula for perimeter of a rectangle is 2 times length plus 2 times the width. Sorry there. We can go ahead and say this is the length of 12 yards, and we know the perimeter. So instead of the p, we're going to plug in the 36. 2 times the length of 12 plus 2 times the width, which we're trying to solve for. So 36. 2 times 12 is 24 plus 2w. So this is solving a two-step equation. Get rid of the 24. So we get 12 equals 2w. So divide by 2 on both sides, and we get that 6 equals w. So my width is 6 yards. So now if I need to find the area, I'm just doing length times width. So 12 times 6, the area is 72 square yards for this garden. This last example is going to take us kind of into our next lesson. It says find the area of the unshaded region of the square tile with a circle inside of it as shown. So round to the nearest tenth. So what we have to realize is that this is a square and we want the unshaded region. So we basically want these white areas that are around the circle here. So you're probably thinking to yourself, all right, well, if we take that square, take away the circle, we're going to be left with those little corner pieces that are sitting there. You are absolutely correct, and it's really easy for us to find the area of the square because it's just 12 squared. However, finding the circle, we need to realize that going all the way across through the center is a diameter, and from here to here, the whole entire thing is 12 centimeters across because it goes across the whole square. For the radius then, you need to realize that it's 6 centimeters because it's only half of it. So basically, for us to get the area of those things, those little pieces, we're going to have to do the square minus the circle. So the square is just going to be side squared, and the circle is going to be pi r squared. So for our square, it's 12 squared, minus, and here we're going to have pi times 6 squared. So 144 minus 36 pi, that's our actual exact answer. And if we were to actually multiply 36 times 3.14, we're going to get 144 minus 113.04. And if we do that, we end up with 30.96 square centimeters then for those little areas. We're going to also continue on with this lesson and talk about the next thing that's in your notes. It's called perimeter of a circle. Circles, you can actually calculate their perimeter, but because they don't technically have straight edges that we're able to see and actually measure using a ruler, we call the perimeter of a circle the circumference. It's just a special name for it. So the circumference of a circle is found by doing 2 times pi times the radius. So in example 1, it says to find the circumference. This right here is your radius, and it is a 5. So our circumference is 2 pi r. So 2 times pi times 5. Just like before, we could do the 2 times the 5, so we're going to get 10 pi. Remember, that's your actual exact answer. And when you do 10 times 3.14, you get 31.4 centimeters. Since it's just going around the outside, it's just centimeters, not centimeters squared. In this example, the diameter is 8, so the radius is just half of that. So the circumference is 2 pi times the radius, or 2 pi times 4, which is 8 pi, which is approximately 25.12 centimeters. Last example here, Reagan's making a cylindrical gift box for a baby shower she's attending on Saturday. The box will look like the picture, and the radius on the circular base is 5 inches. Everything is done except for this ribbon that goes around the outside of the box. What length will she purchase? Well, that's her circumference, and her radius is 5, so 2 pi times 5, so 10 pi, which is going to be approximately 31.4 inches. If the ribbon costs 9 cents per inch, how much will the length of the ribbon cost her? Well, in order to buy this, she's going to have to buy 32 inches at 9 cents each. And she's going to spend $2.79 on ribbon.